Hi students, welcome back to Unit 8, the Pythagorean Theorem and Irrational Numbers. Today we are on Day 5, Rational and Irrational Numbers Part A, and we are answering the big question, what is the solution to the equation x squared equals 2? Again, I am Emma Reed, I am an 8th grade math teacher, and I will be doing this math along with you today. So we have a two-part launch today, and the first part of our launch is to consider the equation x squared equals 49. And your question to answer here is, could 8 be a solution to this equation? Why or why not? Pause and think about that one. And when you're ready, we'll go on to part 2 of our launch, which is related, but not exactly the same. In part 2, your goal is to find a positive solution to each of the following equations. We have x squared equals 36, x squared equals 1/4, x squared equals 9/4, x squared equals 49/25. And I suggest in any situation where you have multiple questions to answer, start with the one that's friendliest to you. So pick the easiest one to start, second easiest, and that way you have some ideas to share if there's one you're still stuck on. So pause and think about this one and put your answers in the blue boxes. And when you're ready, we'll move on to our Explore section. Now we are on slide C of your Explore section, and we're going to do a drawing activity. So you're going to have the option to draw directly on these slides if you're using Pear Deck, or you can grab a piece of paper or graph paper if you have it to draw by hand if you prefer. Another option is to take and save this picture and open it in a Jamboard if you are not able to draw directly onto Google Slides. It's really important that you draw though, so if you do not have that technology, make sure you grab a paper and pencil. So in this activity, we are going to draw 3 different sized squares, and on the next few slides, you'll be asked to draw some squares on a 2x2 grid that follow the rules below. So our first rule is that we need to draw 1 square on each slide. The second rule is that we need to make sure that each square you draw is a different size than the others. That's our 3 differently sized squares. And finally, we have to make sure the square's vertices are aligned to the vertices of the grid. So let's move on to slide D and make sure we know what vertices are. Okay, so on slide D, it tells us that we are looking at 2 non-examples of the types of figures you have to draw. So these are two figures that break at least one of our rules from the previous slide. So on the left, this figure has vertices aligned to the grid, but it fails our criteria because it is not a square. So we can see, right, the height of this rectangle is not the same as the width, so it is not a square. And when we're looking at the vertices, to think back to what vertices are, I'm showing you the vertices of our rectangle right now. It has 4 vertices. And if I'm talking about just one of them, it's called a vertex. So you can see I've kind of highlighted for us each vertex. And let's show some other vertices of the grid that are not part of our shape, just as a reminder. So here's another vertex, and here's another vertex. So this shape did align with the grid's vertices, it just isn't a square. And then on the right, we can see this looks like a square, but it fails our criteria because it doesn't have vertices aligned to our grid. So you can see we have, this is a vertex of the grid. Here's a vertex of the grid. But the vertex of our square is not lined up to a vertex on our grid. So it fails that criterion. So hold our rules in your mind from slide C. You can always look back to check if you need to. Remember these non-examples on slide D. This is what not to do. And now on the next 3 slides, you're going to draw 3 different squares, and each one needs to be a different size. So you'll do this 3 times on slide E, F, and G. It'll look exactly the same, but you're going to make sure that each of the 3 different squares you draw are a different size. And for each square, you're going to answer the question, what is the area of the square you created? What is the side length of the square you created? And what is an equation that relates the length and the side length of this square? So start on slide E, draw your square, and then move on and do the same thing on slides F and G, making sure to answer all 3 questions on the right. So pause and take the time you need to do 3 differently sized squares on slides E through G. Now that you've had your time to draw your 3 differently sized squares, talk about the side length, talk about the area, and show how they're related with an equation, we're now on slide H of our Explore section. And in our work on the previous slides, we may have come across a square with an area of 2 square units. If a square has an area of 2, its side length is not an integer. Let's explore different ways to indicate the side length of a square with an area of 2. So the first way on the left is to give a range. Between what 2 integers would the side length be? In the middle, another strategy we can use is to give an estimate, using a fraction or decimal, about what length would the side be. Finally, on the right, use notation to be exact. How could we represent the exact side length using some kind of notation that we know? So pause and think about slide H. And once you've had enough time to think about slide H, move ahead with me to the summary section. And as we summarize, we're going to respond to the focus question, which was, what is x when x squared equals 2? Excellent work. Thank you for joining me today, and I'll see you next time.